Hello everyone, welcome back to the series Object-Oriented Design Patterns. In this particular video, I'll walk you through state pattern. What is state pattern? A state pattern allows an object to alter its behavior when its internal state changes. This is like encapsulating all the changing states into separate classes or entities. Let's look into a small example to get a clear understanding. We have known how traffic signals work, and these traffic lights will be of three colors: red, yellow, and green. So the red light is one state to the traffic signal. Later, the red light will move to yellow. The yellow light is also another state. Similarly, the green. So this is the changing of state from red, yellow to green. In state pattern, red, yellow and green will be encapsulated into separate entities. In state pattern, the traffic signal pole is the orchestrator, or also called context, and these lights like red, yellow and green are the states which will be keep on changing. Let's look into a general class diagram of state pattern. We have a context, the one which calls the state or which is the orchestrator that alters the state of the design. From the previous example, traffic pole is our context, and we also have state interface which will consist of all the operations. All the concrete states will be implemented by this interface. If you look closely, the state at any particular time will be composed in the context. The current state variable in the context will hold the state of the system at any particular time. This might vary from time to time. Like if the signal color is red, then the current state will point out to red object, the red entity. Later, if it moves to yellow, then the current state will hold the object of yellow class, the yellow state. This is how all the states which are encapsulated will keep on changing based on time intervals or based on its behaviors in the context. Why do we need all the set of operations in every state? Like when I am in red color state in the traffic signal system, why do I need to have the operations of moving to green light? Because I need to have the intermediate state of going to yellow and then to green. Just think of it for a second. This is because the context is only the caller, the one who calls the state, but the context does not know anything about the implementation or the logic behind it. So each and every state will have their own behavior and own brain. Like if I am in a red signal, the context says that you need to move to green, then we will implement a method that this is not the correct way. We should not move to green directly. We need to go to the intermediate yellow state. We'll just throw an error. And if I want to add any new concrete state, like if I want to add another color like white in the traffic signal, maybe hypothetically, so then we will just add a separate concrete state number 4 and implement it on state interface. But there is a problem here. So if I implement a concrete state 4, then I need to have operation 4 which needs to be implemented or which needs to be added to each and every concrete state. This is not correct because this does not obey open close principle. What is open close principle? A class should always be open for extension and closed for modification. We should not go inside a class and do the necessary changes. The state should not be an interface, that should be a class which can be inherited by concrete state 1, 2, and 3. So, the state will provide an abstraction between context and the concrete states. This is how we can obey open close principle. Now, if I want to add any new concrete state, number 4, I'll just simply add it and inherit all the properties of a state parent class. You'll get more understanding further in the video when we start designing and implementing a problem. Let's look into designing of a vending machine. So this is a vending machine. We want to design and implement the software with all the operations in a vending machine. How this vending machine works. First, any customer will select an item in the vending machine. Later, the customer will insert the coin and pay the amount. After successful payment, the product will be dispensed by vending machine. So these are the operations we have in a vending machine right now. We have to implement these operations on the vending machine. Traveling this far in the video, you might already get an idea of what is the context and what are the states in this particular problem. The vending machine is our context, whereas select item, insert coin, and dispense are the operations for the vending machine. Now we need to define our states from this operation. When an item is selected, the vending machine will be in the item selected state. Later, when the coin is inserted, the vending machine will be in has money state. That means the vending machine already has money. Someone has inserted a coin. Similarly with the dispense. What happens to the vending machine after a product is dispensed? Then the vending machine will be in stale, or we can say it will be in ideal state. This is how we're going to define the state. So the state is defined based on the operation. Let's look into class design of vending machine. We have the context. The context is vending machine. It has a variable current state which holds the current state of the vending machine, and it has some operations. This is the forefront object will be interacted with the customer. Like if a customer press any kind of button, all the hardware will contact or will communicate with this class. It has couple of methods, and look closely with the set state method. So this method is the setter method for current state. And we have a state class. It has some methods like insert coin, select, and dispense. We have concrete states, like these are some of the states of vending machine. The vending machine will be in ideal state, or item selected state, or has money state, and dispense state. These states are defined based on the operations on vending machine. Now, if I want to add a new state to this design, think of a refill. Since the state is a class, not an interface, it will be easy, because the refill method need not to be implemented on each and every class, each and every state, like item selected state, has money state, or dispensing state, because refill can be done only if the machine is in ideal state. We don't do a refill if someone is already using the machine, right? So that's why it's better to keep the state as a class rather than an interface, for the flexibility and to obey open close principle. Let's look into the implementation of a vending machine. These are the methods in the vending machine. This is our context. Whenever user try to insert a coin, then we will use the current state variable and call the insert coin method inside it. Similarly, with the select item or dispense, the set state method will be used by the concrete states to change the current state variable in the vending machine. So, the vending machine class will have full authority over its variables and methods. So, no one outside can directly change current state variable. That's why it is better to have a setter and getter methods. Let's look into the state implementation. We have the state class. This is our class where we have three methods. These are the three operations on vending machine. This particular class will act as a layer of abstraction between the context and the concrete states. We have ideal state, which is inherited from the parent class state. Similarly, once the money is inserted, then the vending machine will be in has money state, and so on. These are all the concrete states which are inherited from the state class. Let's think of a simulation to get better understanding what is happening here. Now, a customer walks into the vending machine and first the vending machine will be in ideal state. So, he select an item first. Then the select item method which is there in the context will be triggered. It will call the ideal state select item method. Here we are passing item code as an argument, and also we are also passing context, that means the vending machine class, to each and every state. So this will helps us to move the states, to change the current state variable in the context. Once the select item method is triggered from vending machine in the ideal class, then we'll select the item. Later we need to change the state of the ideal state to item selected state. This is where we use context and set state method to change the state of our machine. Now the state in vending machine has changed from ideal state to item selected state. Then the vending machine will trigger insert coin method in the item selected state, where the user or the customer will insert some coin and do the payment. Once the payment is successful, we need to change the state of the vending machine, where it will move from item selected state to has money state. That means the payment is successful. Later, the vending machine will trigger the dispense item from has money state. This is how the product will be dispensed. So this is the entire flow. You can think of, why does ideal class require insert coin or dispense item? Imagine a user comes into the walking machine and he don't select any item. He or she will just insert a coin. That is not our desired flow. That's where we need to throw an error to the vending machine and to the user. Once all the flow is completed, we will loop back again into the ideal state of the vending machine. That means we will change the current state variable in the vending machine into ideal class object. So this is how the state of vending machine will be changing based on the operation from class to class. Where can I use the state pattern? We can use in e-commerce order processing or multimedia. you will find in the video players, like we need to pass the video or play the video. These are some of the states in the multimedia, places where we need behavioral variance and complex conditional logic. You can think of, if an operation is going to change the state of the machine, at that particular cases you can use a state pattern. Like I was saying, state A is doing an operation A, state B is doing an operation B, and so on. That will be a great way, a flexible way, rather than a single state doing all the operations. With this, we have come to the end of the video. I hope you enjoyed the video. Thank you so much for watching. I'll see you in the next video. Bye.